everyone. Welcome to Modernizing Legacy Apps for the Cloud. And we are excited to bring this to you as part of the Kong Summit Digital 2020. My name is Nancy Wang. I am the General Manager of AWS Backup, which is a managed data protection service that is run on top of Amazon Web Services, servicing and protecting data for some of the largest Fortune 500 customers out there. Super excited to be joined by my colleague, Pranava Adduri. Pranava?
Thank you, Nancy. Hi, everyone. My name is Pranava. I'm an entrepreneur in residence at Greylock Partners. We're an early stage fund in the Valley. I worked as a founding engineer at unicorn startups in the past, infrastructure software. And most recently, I was over at Amazon Web Services, where I worked to scale a brand new product line to over $200 million in run rate. Again, excited to be here. Cool, so let's dive right in.
Sure. So one of the top topics and questions that I receive from Fortune 500 customers that I work with is, now that there's a cloud, right? And there's so many different benefits and ease of use, total cost of ownership savings, and ease of use for administrators. There is a growing need to modernize your applications and make them cloud ready. So really, what does that mean, right? So let's use this time to distill. There are many ways to modernize, which my colleague Pranava will cover in a second. But for the purposes of this presentation, we'll be focusing on cloud modernization methods. So let's start. App modernization is the process of taking existing legacy applications and migrating their platform infrastructure and the infrastructure to use modern cloud-native tech stacks. Modernization itself is usually associated with decoupling monolithic applications. And while this is just one form of modernization, as we can see, modernization itself can take many different forms. Pranava?
Going off of that, so when we think about modernization, there's a couple of major categories of a modernization that we see. I've adapted this from an AWS blog, but the four broad categories that we see are rehosting, replatforming, repurchasing, and refactoring / re-architecting. And just to go a little bit into what each of those are. Rehosting is your proverbial lift and shift, where you take workloads that are running on-prem, say on a virtual machine. You take that workload, maybe the underlying disk image of that VM, you migrate it to a cloud service provider and bring it up on a VM there. Replatforming is proverbially also referred to as lift, tweak, and shift, where parts of your stack you will migrate directly, and other parts of it you might tweak to leverage a cloud-native solution, like a database as a service, for example. Repurchasing is the process by which you discard an on-prem offering in favor of something that provides similar business value, but directly on a cloud service provider. And then finally, refactoring and re-architecting is when you take an existing monolith or a certain application code base and completely rebuild it for the cloud. So this usually involves taking advantage of cloud-native constructs and designing specifically for the cloud. Next, we'll actually see what that modernization path looks like for those four types of modernization that I outlined. As we can see here, rehosting is one of the most direct paths involved. You lift your workload to the cloud, usually in the form of taking a disk snapshot of your virtual machine, migrate it over to a platform like AWS, and then bring up a virtual machine there, running that underlying disk image. When you do a replatforming, you're modifying some of the underlying infrastructure. Again, these all converge, take note, at the last three steps, which is validation, transition, and production. But in between, there's a couple of more steps involved, depending on which form you take. Finally, the last branch I wanted to show, which is the most complicated one, is refactoring. This is where you have to go back to the business objectives of your application, determine what it is that you want to build, and then using cloud-native constructs, rebuild that application architecture to get that going. Usually, of all these four methods of replatforming or modernization, refactoring will usually be the most time-intensive.
And to Pranava's point, refactoring is not only time intensive, but will also involve many complex steps. So Pranava, can you give an example of an application or maybe a customer use case that has successfully gone through that refactoring process?
Absolutely. So an example of something like this would be, let's assume you have an event-driven system where you're monitoring sensor data. And when you were on-prem, let's assume that you had built an internal system to handle events coming from sensors and update a database correspondingly, right? When you transition to, say, AWS or Azure, they all have, or GCP, they all have their equivalent of serverless functions. Now, serverless functions are a great way of doing stream processing. And so what you can do is have your sensor data be sent to your serverless functions, which in turn can be, you can have the event processing logic there that can in turn update like a cloud database of your choice. So instead of having a fully inbuilt event processing system, you can leverage these various cloud constructs to build up systems like that.
That's a great example. And in fact, that actually ties us really nicely into our second section of the presentation, which is why should you, as maybe a CIO or infrastructure of a large enterprise, choose a modernization path, right? And some of the paths that Pranava just outlined can be maybe long or complex. Well, that means that there are some clear benefits, right? So let's start out with one of the benefits, of course, is reducing cost. So what does that mean? When you examine your P&L, oftentimes you have operating cost, right, which then translate into your operating margin. You also have CapEx costs. And so by modernizing your application for the cloud, you then get to leverage some of the cloud elasticity or the subscription nature of the cloud to translate your CapEx costs into OpEx, which oftentimes, as we know today, makes your finance person happy. Second of all is the simplification. So modernizing helps you to simplify your operational overhead by offloading responsibilities to managed services. So as Pranava had given an example of serverless functions, another example of simplifying your infrastructure could be, let's say before you migrated your SQL servers onto RDS, maybe you ran them on dedicated hosts or you ran them on physical servers. Well, as a database administrator or DBA, it would be your responsibility to manage the host, to patch the host, to update the host, which are all things that a managed service such as RDS will take care of for you. Another example in a similar vein is also running your own TensorFlow or PyTorch deployment, right? Whereas you could then simply onboard to a managed service like SageMaker that is fully managed. Third, leveraging the efficiencies. So if you're using something like S3, right, a lot of work is put into making sure that it's reliable, of course, right? Whereas, if you modernize your application, you get to leverage the efficiencies, the reliability, and robustness of modern tech stacks. And lastly, of course, is attracting talent, because as we all know, working in the Bay and in startups as well as big companies alike, no one wants to work on a legacy code base. Top talent is always looking to learn and grow and really get into the weeds and get their hands dirty with the latest languages and latest tech stacks. Now I'll hand it over to Pranava to walk you through some of the gotchas of modernization.
Thanks, Nancy. So yeah. I think Nancy did a great job outlining the pros and the reasons why teams would want to modernize. But then with that does come some gotchas. So one of the most common one is comes down to timelines. So depending on the modernization strategy that you choose, and I outlined the four most common ones, there may be significant replatforming and re-architecting involved. This in turn can lead to long development timelines, especially if the effort is not scoped well up front. And these increased timelines will inevitably lead to increased migration costs. So next, we talked about how timelines can lead to cost, but in addition to longer timelines and dev cycles, modernization for the sake of modernization can actually end up costing you even more than not modernizing at all. For example, let's assume that you modernize via rehosting. That is, you take a on-premise VM, you migrate the disk image up to a cloud provider, and you power on a virtual machine in the cloud. Now, in the cloud, you have variable costs. You pay for the size of your instance for the duration that your instance is being run. Normally, when you replatform, people end up over-provisioning their virtual machines because they want to make sure that the workload doesn't get compromised in terms of performance. So what happens is when you have a powerful VM running on the cloud, you can quickly add up in terms of costs. And quickly, you can actually end up spending more on the VM than had you just kept it, than the net cost you would have had you just kept it on-prem. So when you do a modernization, you need to carefully plan what that looks like.
And out there are many cost calculators offered by, let's say, AWS, Azure, GCP, as well as third-party providers that can help you plan out your migration journey, as well as the TCO that you might expect every phase of the way.
Cool. Next, and really important, is the security landscape. Because regardless of the type of modernization that you end up choosing for your team, you will be operating in a new landscape. As such, you will be dealing with new platforms and architectures, and accordingly, you will also be dealing with a new threat landscape. So as a result, your approach to security and the tooling that you used while you were on-prem or in your previous tech stack might not necessarily adapt to this new landscape that you're going to be operating in. So for example, with a lift and shift operation, at minimum, you'll have to deal with security groups if you're using AWS. And ideally, you'll be setting up a web access firewall, a cloud-native DDoS protection, for example, again, on AWS, something like AWS Shield. And you'll also take the opportunity to shrink wrap access to your workloads, i.e. set up zero trust and migrate away from perimeter security models. So these are examples of how in a cloud-native landscape, the way you would go about securing your workloads would look different. Next, I wanted to go over something that's very common with different cloud service providers, which is the shared security responsibility model. Now, a common misconception that people have is that a managed service will also manage security for you. That is, if AWS, Azure, or GCP are managing your virtual machines or your object storage, then they're also handling security for you. And this is a very common misconception. Most cloud providers operate on a shared responsibility model. That is, you, the customer, are responsible for security in the cloud. The cloud service provider is responsible for security of the cloud. So let's take a look at what this means. I've borrowed another image from an AWS blog post, but to motivate an example here, let's take a look at customer data. If using AWS, you might make use of S3. AWS will handle the security of the underlying storage nodes, making sure, for example, that the storage nodes themselves are patched, updated, and locked down. That is, there's no way for the environment that the hosts are running on get breached and that the environment itself is secure. However, determining who has access to that data that you have placed in these buckets is your responsibility. If a bucket is configured incorrectly to allow public access, anyone can actually go in and read that data despite the fact that the operating system of the storage node has been patched by AWS and that it's physically secure in a data center. Right? So without being properly configured, external parties can access the content that you've placed in these buckets. Determining who has access to this content and buckets is the responsibility of you, the user. If you create a bucket without properly enforcing access controls, you will eventually get compromised. It's only a matter of time. Just because you use a managed cloud service provider does not change that.
And that leads us to understanding, what are some of the compute workloads that you should be thinking about from a security considerations perspective, right? And those include infrastructure as a service, right, of course, which is cloud platforms like AWS, Azure, Google Cloud. Also include database as a service, of course. So that could be, RDS, Aurora, etc., Document DB. Platforms as service, as we've discussed, it could be like SageMaker, for example, which helps you create models on your own. Containers as a service, which of course, again, using AWS examples include, Elastic Container Service, or for example, EKS as well. And then lastly, FaaS, which stands for Functions as a Service. And that is really an interesting deployment model, which Pranava can give you some examples about, where new workloads are being evoked and run. Pranava, would you like to give us an example around Functions as a Service?
Absolutely. So all major cloud providers have their own implementations of functions as a service. The most commonly heard one is probably AWS Lambda, right? So in the same way that, for example, if you have infrastructure as a service, you are talking about raw compute. So probably an EC2 instance in AWS parlance. As you go up the stack in terms of abstractions, you eventually get to AWS Lambda, or functions as a service. And so the idea here is you, instead of building full-on application stacks, you're simply writing functions that get invoked in response to events. An event could be an incoming web request. An event can be responding to a file placed in a bucket. So, and as I mentioned earlier, organizations tend to use Lambdas for event-driven architectures like processing sensor data or reacting to Kafka event streams. And along those lines, part of the reason why FaaS has an interesting threat landscape is that in an event-driven architecture, one event triggers another event. If one of those events can get compromised, or basically if you can compromise one of those Lambdas and get them to start firing by simulating a certain event type or an adversarial event type that they respond to, then they in turn can start causing other Lambdas to get invoked. So that's what we mean by each of these compute workloads has a different threat landscape, and they need to be addressed when you consider a cloud native environment.
Absolutely. And not just from the compute perspective, but also storage. So if you think about block storage like EBS, object storage like S3, and Pranava gave the form example around public access to S3 buckets, network-based storage, which can happen over certain protocols that could also have the opportunity to get compromised. And that all emphasizes the importance of making sure that your data is governed appropriately. And where to better start than understanding what are all the resources that you have in the cloud. So one of the AWS services that is very interesting in that sense is AWS config, which by using config rules, you can discover out of, let's say, my 2,000 EC2 instances that are currently running and powered on, how many of them are being protected? Or something that I care about as a GM of AWS backup is how many of those instances or workloads are being backed up, right? On what schedule? How are they life cycled? What is the percentage compliance coverage of my different resources? And so it's really important as you start modernizing those applications from, let's say, on-premises to the cloud, that you find the cloud equivalent for what was used pre-modernization for data governance. And then lastly, moving on to identity, identities, of course, must also be governed. So coming from the data protection world, a very key concept is RBAC, which stands for role-based access control. And then tying back to the example, again, that Pranava provided around S3 buckets, if you provide public access, right? Or for example, if you enable certain roles to have administrative access, that means they also may have the ability to mutate data. So which is deleting data, editing data. And so is that something you want? And that is a major consideration when, for example, powering on your workloads and ensuring access via IAM, or identity access management, which is a very core principle and concept for all AWS AWS users, right? There are certain managed roles that certain services operate. So to give you an example, with AWS Backup, we have the backup administrator or full access role, which enables users using that managed role provided by the AWS Backup service to create backups, to delete backups, to edit backups. And then there's also the AWS Backup operator role, which only enables you to create backups and restore backups, but not be able to edit or mutate backups. So that is just one example of a specific service and how the service uses managed roles or identities. And so some things to keep in mind, right? Roles should be managed to ensure that identities don't have unintended privileges. So as I mentioned, do you really want this role or user who assumes this role to be able to delete things, right? Or be able to delete very mission critical things. And then of course, avoiding the toxic combination of roles that lead to unintended privileges to roles.
And just to add some stats to that, Nancy, is IBM releases an annual report on the cost of a data breach, and in the 2020 edition, they attributed 19% of data breaches due to compromised identities, and another 19% due to misconfigurations. That is, maybe an S3 bucket that has too wide view privileges where the public can access it. But just to double click on that 19%, you want to make sure your identities are scoped to a as needed basis and nothing more, because if an identity gets compromised, if you have your identities locked down and scoped down so that they only are able to assume certain roles, then the blast radius of that compromised identity is minimized, or at least as minimal as can be. However, if identities and roles are not right-sized, but they're expansive and every identity can do everything, then any one of those compromised identities can lead to a ginormous blast radius.
Absolutely. And that's why it's very important as you're designing your workloads to make sure that you have RBAC finalized and you have what is the permissions model. And so moving to the last section of our presentation, which is what are some recommendations, right, or best practices that we've seen customers do when they think about modernization. So I'll talk about the first one, then I'll pass it to Pranava. So the first one is what is a Cloud Center of Excellence, or a CCOE. Why is that important? Is actually coming from a product perspective, and I was a product manager before assuming head as a service, is that product teams will be focused on how to migrate functionality to the cloud. Of course, product teams will probably not know all the best practices of what to use when migrating or learning how to do things securely. So having a Cloud Center of Excellence, or a CCOE, whose sole job is to really understand this, disseminate knowledge, will greatly ease the journey for all parties involved. And so if you're a large organization, oftentimes you'll have many disparate teams of IT, finance, HR, tech, so on and so forth, that all may be looking to modernize their applications to the cloud. And so some key examples or concrete use cases of a CCOE could be, building reusable deployment packages that align with your organization's security, compliance, and service management policies, possibly, serving as that advisory board or governance body to review, approve, and also govern the use of cloud native tools. And then over time, really the crux of a CCOE is to standardize and also automate the commonly needed platform components and solutions. Over to you, Pranava.
Thanks, Nancy. And just to add one more bit to that, the idea is that with a CCOE, your product teams and your eng teams, they're going to be focused on the re-architecting efforts involved. They're going to be focused on the eng effort involved, right? And it might not, the best practices might not necessarily be commonplace. And so really we've seen that orgs that invest in a CCOE really do tend to come out on top on the other end when they finish that migration. So the last thing I wanted to go over is security opportunities. So we've talked about several different ways security is required in cloud-native environments, and I'll go into each of those domains and what solutions that you can deploy in each of those domains. So most cloud service providers offer solutions for the things I'm about to address, and there's many third-party solutions as well. So it's important to make sure that you pick a solution that works for you, but here are the terms to look out for. Cloud Workload Protection is the idea that when you have workloads, for example, we identified IaaS, FaaS, and various compute workloads. Cloud Workload Protection is a suite of solutions and offerings that help actually protect those workloads. That is, when you have a virtual machine running, actually ensuring that the virtual machine is not running a compromised OS version, or it's not running a compromised binary, right? So Cloud Workload Protection deals with actually ensuring that the workloads that you are running in a secure fashion, they're not compromised. Then there's Cloud Security Posture Management, which is the domain of have you configured your cloud resources so that you have that you're guarded against possible attacks and possible adverse situations. An example of this would be configuring your S3 bucket so that the roles that can access or identities that can access certain buckets is limited, configuring it so that they're not publicly accessible. These are all in the domain of configuration. Another example of configuration might be setting a policy where identities have to change their password every 30 days. These are all different configurations that you can bring to your cloud practices to minimize the possibility of being compromised. And then, if you are compromised, minimizing the blast radius of that compromise. Finally, we also have cloud access security brokers, which is making sure that for the data sets that you have, especially in your SaaS workloads, those are being shared correctly, and those are being accessed correctly. Next, if re-architecting, leverage the opportunity to embrace zero trust and least privilege practices. The idea of zero trust is you should only have access to what you need. Just because you have access to something that you need does not mean you should have access to everything else in a certain network. Right? And this is really migrating from a more traditional model of perimeter security, where the idea being that if you get past a VPN or you get past a certain firewall, everything is accessible. The analogy to use is a castle moat. Right? If you get past a castle's wall, typically everything within the castle is openly accessible. Versus embracing zero trust would be the equivalent of every room having an RFID badge scanner and you having to have access to each room. Right? So by locking down as much as you can, you definitely limit that blast radius in the event that you are compromised. Finally, work with your CCOE to ensure everyone is sharing these best practices. It's very easy for different teams to be modernizing at their own pace, and in the process, they might be adopting different standards. So it's really important for any product and eng team, when they take on a modernization effort, to be in close collaboration with the CCOE to make sure that standard practices are being adopted. This especially becomes useful if the CCOE is also pushing libraries and tool chains so that from the get-go, when you are starting your modernization practices, you're doing it in a secure manner from the get-go. And I think with that, thank you. And if you have any questions, we would be happy to take them.
Of course, and if you're a startup, I'm sure Pranava would be more than happy to hear about your ideas and brainstorm with you. And then likewise, if you have any questions as an organization that is looking to modernize and move to the cloud, more than happy to connect with you. And of course, you might recognize me as well, as I'm the founder and CEO of Advancing Women in Product, or AWIP, a nonprofit organization that is dedicated to advancing women and other minorities in the fields of product management and engineering. And so if you are a woman in cloud product management, I would love to connect with you.
Thank you.